Today, we are going to talk about the two sample t-test. So you have learned about the one sample t-test, but this is a two sample t-test. So in general, there are two types of two sample t-test that we call a paired samples mean test and the unpaired samples mean test. For the most common two sample t-tests are actually the unpaired sample t-test. Let us look at what is paired sample mean test, or we call dependent sample mean test. It actually tests about the differences in the measure of a same group of cases or subject, usually in two different time points. So what they are measuring are actually the same subject that is being repeatedly measured over time in a longitudinal study. So this type of data actually measure the pairwise data set. For example, if you are measuring like the effect of drug A in the heartbeat rates changes, then you can measure the patient heartbeats before the drug and after the drug. And these data are pairwise. So the assumption is the difference in the pairwise measure must be distributed normally, just like in your one sample t-test. Whereas for the unpaired sample mean test, it actually comparing the means of two independent groups of cases. Usually is a cross-sectional study. So the subject or samples, they are independent, and the size of each group do not need to be the same all the time. But for the pairwise or for the paired sample t-test, it is always the same. So the assumption for the unpaired sample t-test are actually the variance in the two groups, it must be similar. So there is one particular number that we need to calculate is actually the pool variance. So the condition is known as homogeneity, and the opposite is actually heterogeneity. So this picture actually show you a clearer summary of what is independent and dependent samples. So for the dependent sample, we do it for the PET t-test. So as you can see over here, so you have sample 1 and 2, but the same sample, they're actually paired. So you are comparing the differences over here. So whereas for the independent sample, sample 1 and sample 2, they are not related at all. So they are independent. Whereas over here, they are dependent on each other. So for this dependent sample, you will be doing the paired t-test. Whereas for the independent sample, they are for the unpaired t-test. So as you can see over here, the size of the samples or subjects, they can be different in the two different population. So this is one of the example to show you clearer when to use unpaired two sample t-test and when to use paired two sample t-test. So this example is that when you need to test if drug A changes the blood glucose level. So there are actually two ways to test this one. So if you want to know drug A actually changes the blood glucose level or not. So the first method is to test this one using a paired sample t-test. So how to do this experiment? So you recruit a group of subjects, and first you do their blood glucose level first. And after this, you let the subjects to consume drug A. So after some time, so you measure again the blood glucose level over here. So in this case, it is the same set of subject so that are repeatedly measured first time and the second time over here. So what are being paired over here is that this, for example, this is subject A. So before the blood glucose level and after consumption of the drug glucose level of the same subject. So therefore, they are dependent on each other. So it's a dependent samples. Therefore, you have to do a paired sample t-test. So the second way to measure drug A, the effect of drug A if we change the blood glucose level, is by conducting an unpaired two-sample t-test. So over here, how you actually do this experiment is by recruiting two different subject groups. So group A, you test their blood sugar straight away. And group B will be the experimental group where you feed them with drug A. Only after that you measure their blood glucose level. So in this group A and group B, they are not dependent on each other. So therefore they are independent. So in this case, for your control group where they do not consume the drug, they are considered as the control group. They are compared with the group that are eating the drug. So you are measuring or you're comparing the mean of group A with group B who consume the drug. So in this one, we are using the statistic of unpaired two-sample t-test to calculate whether if there are significant differences. So the hypothesis testing of t-test is actually the difference between two means. The null hypothesis states that the two samples come from the same population. So in other words, your null hypothesis actually is testing there's no statistical significant difference between the two groups. So always remember that your null hypothesis is always no significant difference. Whereas your alternative hypothesis states that the two samples come from the different population. So in other words, there is a statistical significant difference between the two groups. Okay, so means that they are not the same. So there are two types of hypothesis. A two-tail, where we also call a non-directional hypothesis, or a one-tail, or a directional hypothesis. In the non-directional hypothesis, we are testing that there is no significant difference in your alternative hypothesis. Whereas in your directional or one-tail hypothesis, what we are testing over here in your alternative hypothesis are directional. So it means that usually either testing your first population either is smaller or larger than the second population. So there is a direction over here. Whereas the non-directional over here is stated that there's no differences. Okay, so there's no direction at all. So it can be bigger or it can be smaller. So as long as they are not the same. So these are this is the formula for the t-test. So you need to memorize this. So your standard deviation, standard error over here is to calculate the difference between two means. So and this is the difference between the two mean average. So we will look at an example in for clarity. So you do not need to worry at this part. Let us look at the paired t-test first. So these are the 5 steps you need to remember on how to calculate your paired t-test. First, determine the DI, which is the difference between the paired mean. And then you follow with calculating of the standard error between the pair. So this is stated as SDI. And this is the formula. And the third step, calculate standard error between mean. So the second step is actually between pair, but this is between mean. And the fourth step, you calculate your t value or the t-test. And finally, you compare your t value calculated with the t value in the table 7. Okay, so the degree of freedom is always n minus 1. N is the number of pairs, the total number of pairs in your calculation. So these are the 5 steps over here. First, calculate differences. Second, calculate the standard error. Third, calculate the t-value. Fourth, compare with your reference table 7. And finally, do your conclusion, which means that whether if there is a significant differences or there is no significant differences. So let us look at sample 1. So in sample 1, what you are actually doing is that before a tutorial, 5 students obtained their biostatistics mark of 38, 41, 52, 27, and 18. And after the tutorial, their marks are now 40, 45, 49, 30, and 24. So this one is actually paired. So student A have 38 before the tutorial and 40 after the tutorial. Student 2, 41 before the tutorial and 45 after the tutorial. So follow up this one. The question over here is that we wanted to know whether if the tutorial is actually helpful. So it means that it's actually helpful in improving the marks of student. So the p-value, the significant level is 0.05. So now the question is, do you use paired or unpaired two-sample t-test? So is it a one-tail or two-tails test? And what are the H now and your H alternative? So the answer is a paired t-test, as I've already told you just now. So student A 38 before tutorial, and after that is 40. So it's not independent, it's a dependent sample types. So therefore it must be a paired t-test. Why is it a one tail? Because it is a directional. So what we wanted to know is like whether if the tutorial is helpful. So which means that after the tutorial, the marks are actually higher compared to the before tutorial. Okay, so therefore it is a one tail. There is a direction. So your hypothesis is actually the mean score before the tutorial are actually larger or equal to the mean score of after the tutorial. Whereas your alternative hypothesis is your mean score before tutorial are actually lower compared to the mean score of after the tutorial. So therefore there is a direction over here. So how do we calculate the paired t-test over here? Let us do the first step. Calculate the differences. First, prepare a table like this. So stated over here, the 5 students. So the mark before, which is your x1, and the mark after, which is x2. So it's a pair. So you can see that the size of the population or the sample group, they are the same. So first calculate the differences, x1 minus x2, and then square of the differences, and calculate the sum of x1, the sum of x2, and the mean of x1 and the mean of x2. Okay, so are you done? Let us look at the result. So this is the result. So for student A, 38 minus 40, so you get the difference of minus 2. and the square of minus 2, you get 4. And you sum all of these, like mark before and mark after. So x1, sum of x1 is 176, and sum of x2 is 188. Sum of the differences are negative 12, and sum of the square of the differences are 74. So the mean of x1 is 35.2. So how do you obtain this one? It's 176 divided by 5. There are 5 pairs of numbers over here. So you obtain 35.2. And the mean for your x2 is 37.6. The mean of your differences are negative 2.4. So remember, all of this number we need to use it for the second step. So in the second step, calculate the standard error. So these are the formulas that you need in the calculation. Okay, so how do we calculate this standard error over here? First, you obtain, so this is the sum of differences. Okay, so where is this one? So 74. Let's go back to the first one. Okay, the sum of D2, so 74 over here. This one, D squared, so your differences in square, so the sum of it is 74. Okay, so you replace this with 74 minus the sum of differences. So where is the sum of differences? So the sum of differences is this one, minus 12. The sum of differences, minus 12. So minus 12 need to be squared. Okay, divide by the total pair that you are doing, and after that the whole thing over here divide by n minus 1. So what is your n over here? 5. Okay, so this is the calculation. 74 minus 12 to the power of 12, 12 to the power of 2 divided by 5. Only then divide 5 minus 1. So your answer is 11.3. So do you get it correctly? Now let's move into the second formula over here. So as you can notice over here, the standard error is in square. So now we need to unsquare it. So how to unsquare it? So there's a root square over here. So root square 11.3. So what you obtain is 3.36. So your standard error of differences over here is like get this number, so as the standard deviation over here divided by square root of n minus 1. So n over here is 5. So 3.36 divided by square root of 4. So the answer is 1.68. So your standard error over here is 1.68. Okay, so let's move into step 3. Calculate the t-value. This is the formula that you need to remember also. So how to calculate the t-value over here? x1 minus x2 divided by your standard error. Okay, so what is your x1 minus x2 over here? So let's go back into the first page over here. So this is the mean of your x1 minus x2. Okay, so this is the number that you need to get, negative 2.4. So therefore it will be negative 2.4 divided by your standard error. So what is your standard error? Is this one, 1.68. So negative 2.4 divided by 1.68, your answer is negative 1.43. So this is your calculated t value. Now we are going to move into the fourth step, which is to compare with the reference table 7. So remember, this is your t calculated, negative 1.43. So go to table 7. So where is your table 7? So go to table 7. Let us go to table 7. Okay, so this is table 7. So where are we going to check? 0.05. That is our significant values that we are looking at. So what is the n that you are checking over here? N minus 1. So which is 5 minus 1, and that's 4. So the number is 2.132. So remember over here, this number is plus minus, it can be a minus 2.132 or is a 2.132. Okay, so let us go back. Okay, so the t tabulated of degree of freedom is 4. So your significant is 0.05 and the number is 2.132. Why is it a negative over here? So as I've already mentioned, so it can be a negative 2.132 or 2.132. Because your t calculated is actually negative value, so this will be a negative 2. So what is the conclusion over here? So is there a significant difference, or there is no significant difference? So the conclusion, you need to do like this. So this is a normal curve. So draw out, because this is a directional, so this is a one tail, negative 2.132, so which is your tabulated one where you refer to the table 7, and this is what you have calculated, negative 1.43. So it falls within this area, and therefore we have to accept the null hypothesis. So when you accept the null hypothesis, it means that there's no difference before and after the tutorial. And therefore, the tutorial is not helpful at all. Okay, so that will be the conclusion, because you can't reject the null hypothesis. So therefore, you have to accept it. So your conclusion is there is no significant difference in the mean score before the tutorial compared to the mean score of after the tutorial. Okay? So if you have any questions, so you can go to the Spectrum. In the Q&A forum, you can drop your question over there and I will answer you. Let us try another sample. Okay, so in another example. So in example 2, so this is the scenario given. An officer from a company that manages the network of drinking water supply collected water samples from 10 different locations in the morning and in the evening and recorded the pH values. Test if there is a difference with a p-value of 0.05 in pH of drinking water between the two times. So now, is it a paired or unpaired two-sample t-test? Is it a one tail or two tails? What are the null hypothesis and alternative hypothesis? Have you got the answer? Let us look at the answer. This is a paired t-test because it is the same set of water sample that's being measured in the morning and in the evening. So it's a two tails. Why is it so? Because we want to know if there is a difference between the two times. It's not asking about if the pH is higher or lower in the two times being measured. So we just wanted to know whether if there is a difference. So therefore there is no direction at all. It will be a two tails. Your null hypothesis is actually the mean pH measured in the morning is equal or the same as the mean pH measured in the evening. Whereas your alternative hypothesis states that the mean pH measured in the morning, there is no difference in the mean pH measured in the evening. So it's not the same. So it means that there is a significant difference over here. So how do we calculate? The same. Calculate the differences first. Put all your data into a table. So this is the table that we have already filled in. So your location, there are 10 samples over here. So the morning pH is X1. The evening pH is X2. So fill all your data in and calculate the differences X1 minus X2 and square your differences. Okay, so this is the answer. Have you got it correctly? So let us look at one of the number over here. 6.85 minus 6.86. So therefore the differences is negative 0.01. And the square of negative 0.01 is 0.0001. So these are all the sum of your x1, x2, and all the mean. So let's proceed into the second step, which is calculate the standard error. Okay, so this is the standard error, the formula, if you still remember. Okay, so for the first step, get the sum of the differences, the square differences. Okay, what is the number over here? The sum, 0.384. And then what is the sum of difference? The sum of difference, 0.36. So you need to be 0.36 square. So what is the n over here? It's 10. So divided by 10 minus 1, which is 9. So this is the answer, 0.041. So the square root, the second step is get the square root of this. So square root of 0.041, you get 0.203. So therefore, the differences of the standard error is 0.203 divided by the square of 10 minus 1, and the standard error is 0.07. It's quite easy, right? So now let's move into the third step. Calculate the t-value. Okay? So this is the formula of the t-value. So the mean of x1 minus x2. So if you can't remember, let's us go back. So this is the mean value, 0.036. So 0.036 divided by your standard error, 0.07 just now, and then you get 0.514. So this is your t calculated. Now we compare with the reference table. So the t tabulated for the degree freedom is actually 9 because it's a 10 minus 1. And your significant, your alpha over here, your significant number, is actually 0.025. Why is it so? Because it's a non-directional. So therefore your 0.05 need to be divided by 2 because it's in 2 of the tails. So by referring these to your reference table 7, you should obtain 2.262. It's not a negative because this is a positive. So let's make our conclusion. So draw your normal curve. So it's a non-directional, okay, 2 tails. So therefore you divide your 0.05 into 2. So it was 0.025 over here and 0.025 here. So your t tabulated is 2.262. So therefore 2.262 here, negative 2.262 here. And remember, these unshaded area are actually accept the null hypothesis, and 0.514 fall in within here. So therefore, your conclusion is you have to accept the null hypothesis. And the conclusion is there is no difference in pH. There's no statistically significant difference in pH of drinking water between the 2 times. Means that between the morning and evening. So there's no difference at all between the pH that you measure in the morning and the pH that you measure in the evening. Okay, so you can't reject the null hypothesis to say that there is a significant difference. So therefore, the conclusion is no differences. Okay, so these are the one that you do for the paired t-test. So in the second video clip, we will be talking about the unpaired t-test. So if you have any question up until here, please go to the forum Q&A and drop your questions there so we can discuss about it. Okay, so there will be a tutorial after we finish the chi-square one. Okay, so that's all for this one. Please click on the second video clip for the unpaired t-test.